So in this video, I want to go over some more examples of scientific notation, get some more practice with it. So let's say we had 4.57 times 10 to the negative third, and we wanted to put that into scientific notation. So one of the ways that I like to imagine it and sort of visualize it, so let's just draw a bunch of zeros before our number. Right, so it's to the negative power, so that's how many times we're going to be dividing by 10. So we're going to get some smaller number. It's going to be a decimal of some sort. So we know we're going to be moving the decimal place to the left when it's a negative power that you're raising the 10 to in scientific notation. And so let's see, so we're going to be moving it 3 times, so 1, 2, 3. So our number is 0.00457, and that's just how you do the negative exponent. And so we could do a positive one. Positive ones are a little bit simpler. So times 10 to the third. So again, we could use our same visualization strategy. So if we did 4, 5, 7, and now let's just imagine a bunch of zeros after it. So we're going to be moving the decimal place. Now it's to times 10 to the positive third power. So we're going to be moving the decimal place to the right. So it's going to be 1, 2, 3. So 4.57 times 10 to the third is 470. So 4,570. So that's just how you can remember of differentiating whether it's a positive power or a negative power that you're raising the 10 to. If it's a negative power, then you're going to be moving the decimal place to the left, because you want that number to be smaller. You want the decimal place to be moving increasingly to the left, so that number becomes further and further into the decimal places. And if you want the number to be bigger, if the power of 10 is positive, then you want the decimal place to be moving to the right. You want to have more zeros in front of the decimal place. And so that's just how you remember whether it's a negative or a positive power for scientific notation. And scientific notation is also especially useful for doing by hand division and multiplication. So let's do an example with multiplication. So let's say we had 3 times 10 to the second times, let's say 4 times 10 to the third. Right? So you could plug this into a calculator, sure, that would work for you. Or you could probably this isn't that bad of an example, so you could probably also just multiply, you can recognize this is 300, it's just 3 with the decimal place moved twice to the right, and then this is 4,000, so it's just 4 with the decimal place moved 3 times to the right. So, but a much simpler way to do it is to recognize, since everything's multiplied, it doesn't matter what order you're multiplying things in if everything's being multiplied. So you can also, and we can get rid of the parentheses first. So let's actually do that first. So I have this. Really, it's just the same thing. And then, of course, it doesn't matter what order you multiply things in, as I said. So then you have 3.4, or 3 times 4, sorry, times 10 to the second times 10 to the third. So this becomes 12 times 10 to the second times 10 to the third. And so from exponent rules, you can remember if you have the same base, then you add the exponents. So if I had like a to the first, if you're multiplying that is, so if I had a to the first times a to the second, that's equal to a to the first plus 2, or in other words, a to the third. So in this case, when we're working with scientific notation and we're multiplying the powers of 10, so we have the 12, and we're just going to, they're the same base, they're just both 10, so then we're going to be adding their exponents. So it's going to be 2 plus 3, or in other words, 12 times 10 to the fifth. But then you might say, hey, that's still not in scientific notation. The number isn't between 1 through 9. And so you'd be technically right if you wanted to put it exactly as scientific notation. And so you could recognize that 12, if we want to put it in scientific notation, the number is going to have to be 1.2, right? So in order to get from 1.2 to 12, we have to multiply by another power of 10. And then we also have our 10 to the fifth. So this is actually 1.2 times 10. And this is times 10 to the first times 10 to the fifth. We add their powers, so it's going to be 1 plus 5, so it's going to be 10 to the sixth. And this would be your answer. And so you can get this answer fairly easily, actually, without having to, plug into a calculator or set up your multiplication that you can't do in your head. And so that's a real good use of scientific notation. And so another example that I want to do, let's see if I can extend our region here a little bit. So let's say I was doing division. So let's say we had, let's pick some different numbers. So let's say I had 4 times 10 to the 5th over, let's say 2 times 10 to the 2nd. So this is really the same thing as 4 over 2 times 10 to the 5th over 10 to the 2nd. So this first term just becomes 2, and then same bases. You can remember that if you're dividing, you subtract their exponents. So a to the first over a to the second is really a to the first minus 2, or a to the negative first, which would actually be 1 over a. So you subtract their exponents when they're the same base and you're dividing them. So this would become times 10 to the 5th minus 2, which is just 2 times 10 to the 3rd. And you'd be done. And so let's do one more example with this that can perhaps be slightly trickier. So let's see if I can move this guy a little bit upwards. Here we go. So let's say I had this. So I didn't actually really give myself that much more room, but whatever, I have enough room here. So let's do one more example, but let's do negative exponents. So let's say I had this same example of 4 times 10 to the 5th over 2 times, let's say 10 to the negative 2nd. So this is actually equal, so we get 4 over 2 times 10 to the 5th over 10 to the negative 2nd, which the first term just becomes 2, and then it's going to be times 10 to the 5th minus the bottom power, so it's going to be minus negative 2, which just becomes 2 times 10 to the 5 plus 2, which is just 2 times 10 to the 7th, and that would be your answer. So I hope that gives a little more intuition behind scientific notation and how you use it, and maybe how you use it for basic multiplication and basic division. If you wanted to actually do addition or subtraction with scientific notation, for instance, like if this was a plus sign rather than a multiplication sign, then scientific notation doesn't help a whole lot, except for maybe conserving space when you're writing it down. So you'd probably still want to type it into a calculator or do it by hand, the old-fashioned way of adding them up. But anyways, that's how scientific notation can save you a lot of time with division and multiplication.